Alright, today we're going to be going over negative exponents. But first I want to go over a few examples here of just regular positive exponents. So 3 to the 4th power here is equal to 81. So if you just type these in on your calculator, that's where I'm getting these numbers from. 3 to the 3rd power is 27. 3 squared is 9. 3 to the 1st power is 3. And 3 to the 0. We haven't gone over this yet, but anything to the 0 power is 1. Anything to the 0 power is always 1. Hardest thing in math to understand why, but that's just the way it is. So 3 to the 0 power is 1, and then if you look up what 3 to the negative 1 is, that's 1/3. And 3 to the negative 2 is 1/9. So notice that just because it's a negative exponent doesn't mean the value is actually going to be negative. But what you see there is that the negative exponents ones actually turn into fractions. Okay, so see how from the top down, from up here we started with 81, and then as the exponent got smaller, the number got smaller. But then once we got to 1, the number still got smaller, but it didn't go past 0. It just went into fractions and then smaller fractions. Okay, that's something important to notice. Okay, so let's go to the next slide here. So what are negative exponents and what do they mean? They just mean that your variable or whatever you have to an exponent is going to change position. So if the exponent is in the top of a fraction, then you want to move it to the bottom, and this should say if. This is a typo here. It should say if. If the exponent is in the bottom of a fraction, move it to the top. Okay, so here's two quick examples down here. So we have x to the negative 4th. Well, really, that's the same thing as x to the negative 4th over 1. So this one is a top. This one's in the top right now. So I need to move it to the bottom. So I will take the x to the negative 4. I'll move it out of the top and down to the bottom. So now there's really nothing left up here but just 1. Right, because this is 1 times. And I moved it to the bottom, so I made it an x to the 4th. And now the exponent just becomes positive. So x to the negative 4th really is the same thing as 1 over x to the positive 4th, just changes positions. Now this one, you would do the quotient rule, so you would take 2 and subtract 5. So 2 minus 5 is negative 3, so this is the same thing as x to the negative 3rd, and now you know that negative exponents just means they change position. This one would go to the bottom, so this is the same thing as 1 over x to the positive 3rd. Again, you cannot have negative exponents because they are not completely simplified. And let me write here, let's write a few examples here. How about x to the 3, y to the negative 4 over x5, y6. And let's do another example here for x3, y2 over 8. Y x to the negative 4. Okay. So, first example here, we'll look at the x's first. So, we have an x to the 3rd up top here, and we have an x to the 5th down here. Two different ways to do this. Quotient rule would tell you take 3 minus 5, and this whole thing here is going to simplify to x to the negative 2, which we can do. So, let's do that up top. That's going to be x to the negative 2. And then we would simplify the y's. So what are the y's simplified to? Well, we have a y to the negative 4 over y to the 6th. We would subtract, so negative 4 minus 6 is negative 10. That would give us a y to the negative 10. And then what we do is just simplify the negative fractions. And they both are actually negative, so they're both going to go to the bottom of the fraction. So this is really just 1 over x squared, y to the 10th. That's one way to do it. There's another way to do it. That's one way to think about doing it. The other way is to say where are there more x's at. In this case, there are obviously more x's on the bottom, and there are how many extra? There are 2 extra, because this one's 5, this one's 3. So there's 2 extra x's on the bottom. So that means that your answer, you should have 2 x squareds on the bottom. And then for the y's, ask yourself where are there more y's. Well, in this case, also the bottom. and there are actually 10 extra y's on the bottom, so we would put a y to the 10 on the bottom. Notice how you get the same answer by doing it kind of two different ways there. Alright, so you have two options. Number 2, I'm just going to do this one the second way. I did it up here. So 4 divided by 8 will simplify to 1/2. I'm not going to put the 1 up here. I'll just put the 2 down here because a 1's understood. But actually, I can just write it. Just write it. So 4 over 8 simplifies to 1 over 2. Now we'll look at our x's now. It's important. These are in different order. So the x's are first up here, but they're second down here. And that's fine. Just make sure you're focusing on the x's all together when you're simplifying them. So what do we have? We have an x to the third on top, an x to the negative 4 on bottom. So we have more x's on the top, so we know our x's are going to end up on the top. And how many extra do we have? We have 3 on top and negative 4 on the bottom. So we actually have 7 extra x's on the top. And then we would simplify the y's. Where are there more y's at? There are more y's on the top. And how many extra y's are there on the top? There's only 1 extra y on the top. Okay, and I'm getting that number from subtracting, right? I'm taking 2 minus 1. And if you look here, the x to the 7 that I got, that's 7. I knew it was a 7 power because I did 3 minus negative 4. That is positive 7, so that's why I knew the 7 was up here. Now, if we have another example, say the same thing but the numbers are backwards. Say we have the negative 4 on the top and the 3 on the bottom, like this. Alright, so how do I know? Okay, so if I said, where are there more x's, you would say the bottom. And you would say there's 7 extra on the bottom, so I know this can end up being 1 over x to the 7. Or if you did the quotient rule, you would say, you could do this in you could do 2 steps in one. You could take negative 4 and take this negative 4 and subtract 3 because that's the quotient rule. And that's going to get you negative 7. And then because it's a negative 7 as a power, you would therefore know that it had to go in the denominator. So you would say, okay, it's a negative exponent, so I know it's going to be moved to the denominator. So then that would just get you to your final step here. Okay, and that's it. That's all we have to talk about for negative exponents.